Today, there are more devices connecting to the network, and networks are becoming larger and faster every day. Being able to analyze the flow of traffic across the network is an important function in providing the ability to troubleshoot the network and ensure system security. One tool administrators can use is NetFlow. NetFlow was developed by Cisco over 20 years ago to provide a way to aggregate data as it passes through the network. It's used on routers to analyze traffic as it passes in or out of an interface. It gathers data on each flow into a compact record. This differs for the granular and somewhat cumbersome collection of traffic using standard protocol analysis tool. I'm in Wireshark, where we see a number of different packets. Now, we could filter by conversation, and we'll do that. We'll narrow this by one conversation, but you still see many different records. In some cases, we simply want a transaction that reduces the amount of information collected from a communication by combining all of that into a single record. The NetFlow collector will produce a summary of the following: ingress interface, source IP address, destination IP address, IP protocol, source ports, destination ports, type and code for ICMP, and IP type of service. Intrusion detection monitors traffic for unusual or suspicious activity and generates an alert. We can use intrusion detection based on NetFlow. The NetFlow sensors can gather and store network transactions and can monitor traffic for anomalies, such as detecting network scans from an external source, denial of service attacks, and hosts communicating to a command and control server. NetFlow aggregates events as it passes through the network. I'd like to show you in Packet Tracer how this works. I'm in Packet Tracer, and here you see the NetFlow server. I'm going to go in and we're going to just show you how to get to the NetFlow collector and analyzer. We open it up, and we do want to turn that on and start it up. Now I'll generate some traffic. I'm going to go into Laptop 1 and to the web browser. Over here you see the web server and that IP address. So I'm going to enter that IP address, 192.168.40.100. And now I see the Cisco Packet Tracer web page. Let's take a look around. There we see a small page, copyrights, the image page, and a simple image. All right, now let's go into the NetFlow collector, and what we can see now is it's aggregated that. Now it's going to run through the aggregation. It takes just a second. And now you can see the information it's gathered, such as source address, destination, where it's coming from, the protocol, direction, and other information. NetFlow remains an effective way to aggregate and store transaction data, which can be used for accounting and to identify malicious or anomalous activity, along with creating baselines. Cisco IOS IPS monitors the network and prevents intrusions by comparing traffic against a signature database of known threats. If a threat is detected and triggers a signature, the device can block the malicious traffic. There are several steps necessary to implement IOS IPS. The first thing you'll need to do is download the IOS IPS files. Older Cisco IOS releases had built-in signatures. However, newer versions do not have the built-in signatures. Therefore, you'll need to log into Cisco.com with your username and password, and then download the IOS IPS signature package files along with the public crypto key from Cisco.com. You'll then need to create a configuration directory in Flash to store the signature files and configurations. You'll then configure an IOS IPS crypto key used by IOS IPS. The public key is the text file that you downloaded from Cisco. The master signature file is signed by a Cisco private key to guarantee that it's authentic and the integrity has not been modified, which is very important because you don't want anyone to modify those signature sets. Then you'll enable IOS IPS. First, create an IPS rule name and specify the location. enable SD and logging event notification, and enable syslog if it's not already enabled. All signatures are grouped into categories. This helps classify signatures for easy grouping and tuning. The three most common categories are All, Basic, and Advanced. You'll configure the router to support the default Basic signature set. Those three commands will set the All category as retired. The next set of commands will make the IPS Basic category unretired. Now caution, do not unretire the All category. The All signature category contains all signatures in a signature release. The iOS IPS cannot compile and use all the signatures at one time because it will most likely run out of memory and possibly crash the system. And now you'll need to apply the rule to a desired interface. And here we see the IPS rule is applied to Fast Ethernet 00 and an out direction. Now you've implemented IPS. Now let the system do its job of defending your network. In this demo, I'll configure iOS IPS. I'll enable iOS IPS. I'll configure logging using syslog. I'll modify an IPS signature, and then I'll verify the IPS signature. As a side note, the signature files are already imported on the router. As a result, we don't have to configure the public crypto key or complete a manual import of the signature files. Now, as you can take a look at our topology, we'll have over on the left-hand side would be what we consider our inside network, and then over on the right-hand side, the outside network. The first thing I did was verify connectivity, that those PCs A and C could talk to one another. Let's take a look. As you could see, I did ping PC C and it was successful. Over on PC C, it was able to reach A without any problem. So now we're going to go into router 1. I'll need to log in. I'll go into config T, and what we need to do is enable the security technology package. Now it's a long command, so I'll use tab. I'll accept the end user license agreement, and then I'll save the running config. And now I'll reload to enable the security license. Now I'll log back in. And now I'll make a directory. We'll call it IPS dir. Now I'll go back to config T and I'll configure the IPS signature location. Now we'll create a rule using the IPS name command, and we'll call it iOS IPS. Now we'll enable the timestamp service. Now I'll set the clock. Now I'll send the syslog messages to the syslog server. All right, now I want to configure the iOS IPS to use the signature categories. So we'll retire all the signature categories with the retired true command, and then unretire the iOS IPS basic category. Now we'll exit and accept all changes. Now I want to apply the rule to the gigabit interface. All right, direction out means that the IPS inspects only traffic going out of that interface. Now I'm going to unretire the echo request signature and change the signature action to alert and drop. That's signature 2004, subsignature 0. So we want to unretire it, so it will be retired false, enabled true. Okay, so we're going to tell it the action is to deny packet inline. And now we'll exit and accept all changes. And to just check, we'll just show IPS all. And here you can just see total active signatures 1. So if you're doing any troubleshooting, we have a lot of commands that we can go in to check our work. All right, now what we're going to do is, just to make sure that the IPS is working properly, we'll go back in and we're going to be able to ping A to C, but we won't be able to ping C back to A. Okay, now let's go back into C. And the request has timed out. We'll go into our syslog server and we can see that it's logged some of the events. So we saw that we enabled an IPS and we verified it and made sure that the signature was working as expected.